All right. Hello, everyone, and welcome to today's webinar titled How to Prepare for Lab Automation. This webinar is a part of the 8th annual event in the Laboratory Automation Virtual Event Series. I am Sydney McNeil of LabRoots, and I will be your moderator for today's event. Today's web seminar is presented by LabRoots and sponsored by Automata. For more information about Automata, go to automata.tech. Before we begin, I would like to remind everyone that this event is interactive. We encourage you to first participate by communicating with other attendees using our live chat feature during the presentation. You can find the live chat located at the left of your screen. You can also participate by submitting as many questions as you would like during the presentation. To do so, simply type them into the Ask a Question box and click Submit. We will answer as many questions as we have time for at the end of the presentation. If you have any trouble seeing or hearing the presentation, click on the Help Desk button located at the top of your screen within the navigation bar or from the lobby within the event. Now let's get started. I now present today's speaker, Jesse Mayer, Field Application Scientist at Automata. For a complete biography on our speaker, please visit the Presenter tab from the menu on the left of your screen. Jesse, you may now begin your presentation.
Thanks so much, and thanks everybody for joining. This is actually a topic that I'm really excited to present about because when I was at the bench, moving to lab automation can be really intimidating. You understand your assay well, but it's potentially a lot of new equipment, a new way of approaching and even thinking about how you're doing your science. So what I want to do today is give a brief introduction of how to prepare for lab automation. And I'm going to break this down more or less into a few different topics. The first of which being thinking about when it's time to automate. What are some of the signals that might give you an idea that your assay is ready to move into automation, and maybe some things that are indicators that maybe a particular assay is something that's not quite ready. If you've decided that automation is a good choice, what does developing an automation solution look like? Who do you interact with, and what is the process of designing and agreeing upon a system and the workflow look like? And then last but not least, if you do move forward with an automation solution, what to expect. These are usually pretty complicated systems. It's not something that's just going to show up the next day. It is a project and a partnership. And so getting an idea of what that partnership looks like throughout the whole process. Before we jump into that, I wanted to cover just kind of a couple ground rules. The first being what even do I mean when I'm talking about lab automation? Because that term can cover a lot of things. I've got this kind of spectrum here, and this, there's automated instruments. So that would be the Formulatrix Tempest here on the left, where it's got a stacker that allows you to run multiple plates on the instrument, but everything's really kind of stuck there. You've got liquid handlers that are typically, an integrated instrument that has the main liquid handling function, and then some other devices on there as well, like a thermocycler or some storage for plates. And then you have what I call an integrated work cell, or basically a standalone device where there's no one instrument that's at the center of it. You've got multiple instruments, each providing a specific function, whether it's actually performing the assay or supporting it, with an arm that's moving things around and a scheduling software to back it up. So to be clear, these are all different approaches for lab automation, but today I really want to focus on that integrated work cell part of it. The second thing is just wanted to give a quick background and introduction to Automata and what we do. So we do focus on these integrated work cells and take this from a platform approach. So what you see here on this picture is our link bench. It's our basically table for connecting devices, a modular platform that's really scalable and expands as you go. That's not all that we do. When we work to build lab automation, we put it together as a complete solution that is going to be the hardware, that flexible, expandable link bench that we have, software that's browser-based and a truly modern approach for scheduling software and basically interacting from one instrument to another. And then the support. We don't want to just, deliver these things and say good luck. We want to make sure that you really understand and are comfortable with the automation, and it's something that you're excited to use every day. Obviously, happy to go into more detail beyond this talk if you ever want to talk about what we do here at Automata. Everything else from here, I'm going to give kind of a general focus. These are things that you would expect for any lab automation project that you take on. So jumping into it, the first step is planning for automation, getting an idea of if your assay is the type of assay that's ready for automation. There's a lot of things to think about, but usually when I come across these sorts of projects, there's a few things that really show that it's the right project and the right time to automate. The first thing is when you have a project that's scaling up. I always say that if you have a project that takes a person a whole day to complete, and all of a sudden your research or your pipeline demands that you increase that assay 10 times, the solution is not to get 10 people to do the same thing, because you'll probably continue to scale more from there. I've had diagnostic projects where something that was originally 50 samples a day turns into 5,000 samples a day, and they have a lab of 100 people. And that obviously brings a lot of variation, a lot of complexity into the workflow. So if you see yourself really scaling up, you've got a successful assay that you just want to run at a higher throughput, it may make more sense to change the approach to how you're doing it rather than just duplicating the same process over and over. Another good reason to automate is when you find that you have a lot of instruments that sit idle in the lab on nights or weekends, just because you don't have people there to utilize the instrumentation. There's a lot of really great, solutions out there, but if you look at things like high content imagers, certain liquid handlers, these can be many hundreds of thousands or even millions of dollars. You want to make sure that you're getting your return on investment and that you're using those devices as much as you can. So if you can develop a solution that can make sure that that system maybe runs some plates into the evening when everybody's gone from the lab, that can be huge. And then another good reason to automate is when consistency is essential. The nice thing about automation is once you've developed a workflow, you can expect that workflow to run under those same conditions consistently and constantly. I'm sure we've all worked with different experiments or different assays where some people tend to have a little tighter data range than others. If you want nice, clean, reproducible data that's consistent across the board, automation can really help with that. On the flip side, there are some times when maybe it's not a good project to automate, or something that you may want to consider automating down the road, or even just rethinking how you're working with that assay, maybe finding a new way to do it that would be a little more automation friendly. The first, and I would say most important thing that I think sometimes goes overlooked is if you have an unproven assay that's either really inconsistent at the bench or is something that maybe your lab hasn't tried at all. I was talking in the previous slide about you might have an assay where some people perform it better than others. That's okay. But if it's an assay that the same person may work one day and not the next, you're going to run into those same issues with automation, because it's probably at the assay level that there are some issues. Automation's not going to fix that. Likewise, if you're going to be working with this assay a lot, it helps to have confirmed that it works in your lab and that it's getting you the results you need and the data you need before investing in an automation platform that's built specifically to that. High variability. Automation can, tweak some parameters as far as like how much liquid you need to dispense into a plate, what particular steps, the order of steps as that plate moves through different instrumentation. But if you have a lot of plate to plate or even well to well variability, that can be tricky because the systems are custom designed to the work that you want to do. So if things are going to change from one month to the next, you may find yourself swapping out equipment a lot, and it may be a little more complicated than if you've got something that you're running pretty consistently. Doesn't rule anything out. These systems can be built with equipment to run multiple different assays, but kind of the tighter and the narrower in scope you have, the more valuable the system is going to be. And then speaking of plates, the last thing to consider is what labware you're working with. So we're all familiar with the 96 or the 384 well SBS format plate. That's what a lot of automation is designed around. And with that, the automation equipment that we usually work with. There is some exception, like there are ways to work with things that are shaped a little bit different. But when you move into like large flasks, heavy bottles, things like that need to be moved by the equipment, it can be a little trickier to do. That becomes more of an industrial automation type workflow than a lab automation. So the other thing to think about is twist top tubes. 15 mil conical tubes work really well with hands. They don't work so well with robots trying to decap and recap. So that's usually something where you may want to think, is this something I can move to, let's say, a deep well plate or to a rack that has screw caps that are built specifically for automation. So having covered some of those, maybe good time to automate, maybe time to, look at the assay and decide if it works. Let's say that you've decided on an assay, you're ready to scale up and you're ready to automate. When you reach out to an automation provider like Automata, what does that process look like? How do you get to the solution that's going to drive success in your lab? The first step is going to be introductions. So usually that first call is going to be someone from the sales team to help with timelines and really manage the project and give you, basically guide you through that process. There will also be someone on the technical side, like myself, that's there to understand your assay, understand what equipment you're working with, and make sure that we can develop a really effective solution. So no one of these calls goes the same because, sometimes you really know your assay and maybe your equipment well. Other times it's more of a consultative, your assay, but you're less set on equipment. You're buying new equipment anyways. You want some recommendations. So these really don't have like a set format, but the common questions are usually just starting with, what is it that you hope to automate? What kind of throughput do you need? To focus on that one a little bit, I get a lot of times when thinking about throughput, the answer is usually as much throughput as I can get, right? I want to make sure that I can expand this experiment as much as physically possible. And it's worth focusing on a number that makes sense for kind of your near-term growth, because the type of systems you build are going to be very different depending on what your throughput looks like. So the analogy I like to use here is, if you said, I need to bake 50 cookies a week, you're probably going to build something that looks more like a kitchen in your home, because that's going to be plenty. But if you say I need to bake 5,000 cookies a week, you're probably going to have some sort of industrial automation platform that has, dispensers and a huge oven to reach that throughput. Those two systems, those two solutions would have different timelines. They would have different costs. They would have different complexity, and one would probably be overkill. So we can definitely do solutions at one end of that spectrum or the other. It's just making sure that it's appropriate for the project. The other question to think about is, what type of devices do you need? Because some devices are more or less automation friendly than others. So as an example here, these are two head-edge centrifuges made by the same company, serving the same purpose. But the one on the top is kind of your traditional benchtop centrifuge. It's going to have rotors where you need to load the tubes in manually, a door that you need to press the button to open and close, and then like physical buttons on the front of it to configure centrifuge speed and time. The head-edge centrifuge on the bottom is designed for automation. So it has a door that's very easy to reach and is electronically opened and closed, so we can interact with it from our software side. The speed and time can be configured remotely, and it's designed for plates. It's very easy to work with. So you may have some devices in the lab that are already automation friendly and you just don't know it. This is usually true of like plate readers or qPCR instruments. You may have other devices that work well at the benchtop, but you may want to consider something else to ensure that things run smoothly when you do decide to automate. And then last but not least, what is the biggest bottleneck in your system, right? If we automate something like DNA or RNA extraction and get that really going and moving fast, if you're still manually doing prep for something like NGS, is that now going to be what holds it up? So really starting to think about across your whole workflow, from when your samples start to when your data is out, what could also be a choke point, and making sure that we design a system that focuses on those slowest steps to really speed everything back up. So once that introduction's done, it's usually just like a 30-minute scoping call to get an idea of what you're doing in the lab, what needs you have as far as throughput goes or devices. We can go back and develop a solution that we can present to you. So if you're new to working with Automata, usually that comes with some software and hardware demos. So we have demo sites in Boston and London to actually see the equipment. Can also do that over video. And then obviously anywhere, I'm always happy to go through like a 30-minute software demo so you understand how you'd be interacting with the system. You load whatever it is you need to automate, how you're going to run through it, and how you're going to monitor that and edit workflows as needed. So usually 2 separate meetings to do a software and hardware demo. If you've already worked with the Automata platform, that's not necessary. So then the next step is an initial concept render. I call that rough CAD or scientist CAD because it's usually me putting it together. The picture that's on here at the top is an example of that. So it's just okay, here's the equipment that I think you need or that we've discussed we need. Here's how it would be assembled. Here's a rough idea of footprint, but by no means like the final design that you would receive. Once we've presented that solution and how we initially see it, there's a lot of back and forth because these systems are custom to everyone. And maybe there's a different brand of device that you prefer working with, or maybe as we're having these discussions, you realize you need a second thermocycler. So there's typically a lot of solution refinement. So after that initial design, going back and forth, getting to know your protocol a little bit more through a deep dive so that we can further find those bottlenecks and really make sure that we have the right number of instruments to do everything. With that, presenting some other documents or deliverables. So in this case, a formal CAD, which is going to be done by our engineering team and is going to be more precise about like exact footprint, making sure that the arm can reach all of the devices. And then I put together a workflow through, we use Figma, but any sort of like Visio or Miro project mapping type software to really make sure that we understand every step from beginning to end. Once we've refined that solution and everybody's in agreement that this is exactly what we need to build a really productive and effective automation solution, that's when we get to the final proposal. So this is going to culminate around some sort of document. Here at Automata, we call that the URS, or user requirements and specifications. It can also be referenced as the statement of work or scope of work. But this is going to be the project charter, a document that outlines, here is the system that we're building. Here are the devices that are going to be on here. Here's what we're providing. What devices are you potentially providing from your lab? What do timelines look like? And what is the system expected to do? Just to make sure that everybody's on the same page, that we're happy, and it's something that we can deliver effectively for you, that you're happy. And this is really an assay and a solution that's going to help your lab immensely. Okay, so once we've scoped out that solution, we've got an idea of what it is that we want to build, and you decide to move forward with an automation project. What do things look like throughout the deployment process? There's a lot that goes on, typically weekly or bi-weekly meetings with a customer success manager or a project manager that's going to ensure that everybody's on track and providing information and resources as necessary. But within that project, there's kind of a few major milestones that are going to be associated with getting that automation system up and running. First step is going to be kicking things off, planning what the next few months are going to look like, and getting everything put together. So typically the sites are built, or the instruments and the automation solution are built at our factory, again, either in Boston or London. So any equipment that needs to be purchased, this is the time to do it. If you have equipment that you want tested on the platform, that's when it would get shipped to our site. We're also going to work on planning things out on the software level. So really using that flow chart or that workflow map and starting to put that into the software and developing a schedule of what the process is going to look like. Start simulating that if it wasn't already done in the pre-sales process, and basically collaborate with the lab to make sure that everything looks as planned and the assay in the software is mapping up with how you're currently performing it. Over the timelines here can vary a little bit depending on the device and the scope of the automation. If this is something like a plate reader that's just going to have a few plates fed into it, this can be a very quick process. If this is a very large work cell that's meant to do a lot of different things, then the build process can be a little bit longer. Once everything is put together, the next step is going to be factory acceptance testing, or FAT. You're always welcome to visit and come out to the site where we're performing factory acceptance tests. Alternatively, it's something that we can do virtually, but it's basically going to be running through the assay that the system is meant to do, or assays, as a dry run. So not with samples, just moving dry plates from one piece of equipment to the other, sending the commands for those devices to run, and just making sure everything runs as smooth as possible. It's also a little bit of a check-in for both our team and your team to look at the system and say, this is all running smoothly. This is exactly what I was expecting. Or alternatively, to identify some things that can be tweaked before the system gets sent out to your lab and gets fully built. So again, timing here and the length of the factory acceptance test can vary. For some projects, this can be done in half a day. For others, this would be something that you would want to do over multiple days. Once everything looks good after factory acceptance testing, the next step is site build and site acceptance testing. So systems taken apart, shipped to the lab, brought in, and is rebuilt. And then that whole testing process that was done at factory acceptance testing is repeated this time on site to just confirm everything's working. If there were any things that were identified in factory acceptance testing, they should be corrected by now, and we're able to re-demonstrate that everything's going to plan. And just kind of a final sign-off for everybody to say, this looks good, this is the project that we had envisioned, this is what we want to move forward with. Once we're fully operational, it's then time to, the best part of automation, to get to use it, to get samples on there, and really start getting that clean data and that scalability that you're looking for. Last part, and this is an important part because it's not always true, is making sure that you have a strong base of support after that system is deployed. So for us at Automata, we really focus on this hypercare phase of support. Immediately after it's been deployed, we'll stay on site. Again, timing varies depending on the size of the system, but at the end of the day, we just want to make sure that you're excited to use it and that you're comfortable using it. So the joke we kind of make sometimes is there's always going to be someone in that blue Automata shirt at your lunchroom right after it's built, just sitting there waiting for questions, or sitting on the system, or training, making sure that there's someone you get to know, that you get to know the system well, and that you're empowered and excited about using the system. So once it's handed over, we're going to be in that hypercare phase. We're going to make sure that as you're actually running samples on the system, everything is working out as expected. Once everything is good there, we then typically move on to kind of more of a traditional post-deployment phase, which is going to be 100% available, remotely for resolutions, and can come on site if necessary to make sure that the system's up and running, and also to some extent pivots as you do. Maybe you tweak an assay a little bit. We've given you the tools to do that yourself, but maybe you want some assistance with that. Maybe the project's going to grow and expand. We've got this modular framework for building hardware, so maybe you want to add a couple benches and a couple new devices That's always a conversation we're willing to have. That's always a conversation we are going to have through check-ins over time. So that's what I have for today. I really hope from this talk you've gotten an idea of what you're starting to think in your head what processes in your lab may make sense for automation, that you'll have an idea of what the process looks like as you're scoping out automation, and then what to expect when it's time to deploy, and then most importantly, get to use the system. I've put my email address up here. I'm always happy to answer questions. I've been either supporting automation or using automation for a long time. So it's something that I'm very passionate and excited about talking about. So please do not hesitate to contact if you have any questions. But that said, happy to move into a Q&A session now. If there are any questions I can answer right now.
All right, perfect. Thank you very much, Jesse, for your very informative presentation. We will now go ahead and start the Q&A portion of the webinar. If you have a question that you would like to ask, please do so now. Just click on the Ask a Question box located on the bottom of your screen. All right, let's get started. The first question that we have here is, what do I do if I don't know what my throughput will be?
Yeah, and this is a really good question because things do pivot a lot in a lab. You can think to the future to some extent, but it may not always be clear what that number is going to be. So usually what I would say a good place to start is look at how things have grown in throughput over the last couple of years, or maybe even the last couple of months, and kind of use that as a guidepost to see where you're going. That's the number that we can start with, is a rough idea of how many plates you're going to use a day. But another thing, and this is where someone like myself can help, is looking at the different pieces of equipment and where you might hit a point where a second device is needed, and kind of trading off that additional equipment versus cost. I guess what I'm getting at there is there are some times where another device that may cost a few $1,000s is going to drastically increase your throughput. There's another time where maybe the center of the system is a very expensive imager, and once you go over its maximum capacity, it's going to be a big investment to really scale up from there. So we can help do timings on our end to get an idea of how many plates would go through the system, what devices might need to be scaled up, and just have that back and forth conversation, and figure out if what seems to be the right balance of throughput at the time for the system.
All right, perfect. Looks like we have a few more questions coming in here. The next one is, what are the steps for if/when we outgrow a system? Do we go through this entire process again?
Yeah, so it's not always going to be going through this process over again. You should be working with the same group of people, again, from the initial conceptual design of the system to deployment. So someone like myself is going to know your system really well, and what kind of things we may be able to tweak to scale it up. A really nice thing about the Automata platform and Link Bench is that we have these 1 meter by 1 meter benches. So you can start with 2 if you have a smaller system with a couple of devices, and maybe you want to add parts to the beginning or the end of the assay. It's really easy to add additional benches and string everything together. So it's rarely a complete let's start everything over. It's often okay, you've got this system, what's worked well, what are things that we might want to tweak a little bit, and what would be most effective to expand, and then just kind of basically starting a new project, but that project can just be an expansion or a growth of the existing system.
Great, thank you. The next question that we have here is, considering the recent advances in AI, does the software utilize any such capabilities?
Yeah, so I think there's no industry anywhere right now that isn't having this AI discussion in some way or another. It is something that we're looking into when it comes to method development and how do you speed up that process of designing a workflow. But I guess this isn't something that was brought up in this talk, but is worth addressing. Lab automation itself is just one part of a larger lab workflow. So typically, for certain assays, you'll have data coming in. Maybe you have a LIMS that's providing barcode information or is providing information on how the assay is supposed to run. And then you have downstream software, whether that's on something like the imager itself, or going into like a dedicated data platform that's going to process what happened on the platform and really think about what's going on. And those kind of pieces of software are already integrating pieces of AI. There are imagers that can detect different morphologies in cells based on being fed a number of images. So I would say watch this space. There are already pieces of the lab automation workflow that are using AI. The number of pieces of software that are incorporating this functionality is constantly increasing.
All right, great. Thank you very much. The next question that we have here is, in addition, do you work with mixed media in your systems, like liquids, solids, powders, fabrics, or other form factors?
Yeah, definitely. Predominantly with these type of systems, it's usually liquids that we're working with, because there's a lot of automated liquid handlers that are out there. They're fairly easy to transport. Solids, to some extent, it gets a little bit trickier. It depends on the type of solid, right? There can be things that are preloaded or pre-bound to a plate that are very easy to work with. Powder dispensing, there are devices out there that are integratable with lab automation that would allow you to dispense into like tube racks. It just gets a little more complicated. But this does bring up a good point, that Automata is hardware agnostic. There's nothing that we manufacture on the equipment side outside of our benches, which means that a lot of the discussions we have are, what instruments are you already using? Is there a particular powder dispenser, or is there a particular instrument that you're working with that maybe we can integrate? And then working with our engineers and our drivers team to make sure that that's possible. So I never fully rule anything out, but historically a lot of these systems are liquid based.
All right, perfect. It looks like we have two more questions that have come in here. The next one is, do you do work with sampling handling besides liquids, like with solids, for materials research?
Yeah, so this sounds a little similar to the previous question. And again, I think it boils down to what type of solids that we're working with. How do they get into the plate or tube that we're working with? And what does that downstream workflow look like? So are these things that need to be dispensed on the system? Does it vary like the volume or the quantity of solids, the weight of solids that needs to go on the system? And then what are we doing with it? Is this a dispense, weigh, dissolve? Is this something where we're going to have to do some like downstream chemical analyses? Again, part of the solutioning process and part of that introductory conversation that we would have is getting an idea of what your workflow is, what instruments you currently have, and what instruments would make sense to integrate.
All right, wonderful. Okay, it looks like we have one final question here. Can you talk a little about the post-hypercare remote service that you mentioned? How does that work?
Yeah, so at the start of any project here at Automata, you're going to be assigned a customer success manager, and that is going to be your point of contact throughout everything from deployment through hypercare and in post-hypercare. That's someone that you and your team should know well, someone who should be reaching out just to check in and make sure everything's working smoothly, and be your primary point of contact for that support. So when you get to that hypercare phase, you will have someone on site. Again, someone you'll probably know well, be emailing plenty with lots of questions. And so when you get into that post-hypercare phase, those are going to be your points of contacts and the people you reach out to. Specifically, what that support looks like can depend on a couple of different factors. One, being the complexity of the project. Is this something where it's going to be more, on-site support versus things that can typically be addressed remotely? It can also depend on what you're looking for as far as support goes. We have the ability to procure the equipment ourselves and be the point of contact so that if any of the lab instruments on the system need support, we can triage that support out to the equipment manufacturer for you. Alternatively, you can buy all the equipment yourself and manage those relationships with the individual equipment manufacturers on your own. And then we would just be there to support the software that's connecting everything together and the hardware that we provide, the arms and the benches, or something in between. There's just like these are custom solutions, it's a custom support structure. So there's a lot of ways that we can do it.
All right, perfect. Well, thank you again, Jesse Mayer, for your time today and for your very important research. Please be sure to also check out Automata's booth located in the exhibit hall for more great information. Before we go, I would like to thank the audience for joining us today and for your very interesting questions. I would also like to thank our sponsor, Automata, for sponsoring today's webinar. Questions we did not have time for today and those submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand for 1 year until March 20th, 2025. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, goodbye.